What's up, everybody? Welcome back. Today we are working on my map, and today's topic is integrating bus scheduling. So, the other day we managed to implement bus route planning. So, what we do right now is we have like this map, blue lines are bus routes, and if I go onto the street here and I click like start path planning, it does seem to try to take buses. Now, the way we are doing this bus route planning is pretty rudimentary and stupid. We are basically just saying, hey, like buses, these things are like 10x faster than anything else, which is like blatantly untrue. And so what I want to work on today is trying to integrate bus schedules. So we are using A star to do our path planning. So we kind of say like as we go, there's nothing really to say there. We use A star. We take some data from OpenStreetMaps. We hit street data. We have like attributes that we can like add to here. So we can say like, hey, I prefer to walk on sidewalks. I prefer to not go zigzaggy. I prefer to like, continue going in a straight line, stuff like that, right? So if here I write 3 here, it goes like L shape instead of zigzaggy. And so, the plan for today is transit time. So how are we going to do that? We need to fetch the time for each stop. So right now we kind of track like where the bus stops are right here. We kind of like connect these to the graphs like this, right? So if you do like a typical A star and you say like, hey, I get here, and you say like, now I need to wait for the bus, you can kind of model this as like, when I get here, it's like 12 o'clock, and this bus is going to come at 12:03. So we can model this node cost as basically depending on the time that the bus is going to get here, as well as the time that it is when we get there. But where this gets a little tricky, is that the A star planner basically like relies on the fact that you can predict accurately to some extent how long it's going to take you to get somewhere. So if you have like a bunch of nodes kind of like this, right? And you're trying to get over here from here. The way A star works is it says like, this is cost of 1. And he's going to say like, what do I think the cost from here to the end is? And he draws like, what you do right now is we draw like a straight line from here to here. And he goes like, say this cost is like 2. And he says like, okay, well, I know that the cost for me to get from me to here is 1. And the cost from here is like maybe a little less than that. Maybe that's a bad example. Basically, he tries to predict how far each of his neighbors are. And he knows to basically like that this node here has like a higher predicted distance than this node here. And so because of that, he will not look at this node first. He will only look at this node after he's kind of traveled farther than the predicted distance of that to this node, if that makes sense. So he kind of adds up like the cost that he's walked plus the cost of the prediction. And that needs to make the prediction needs to be smaller than the real cost, or else we will not ever, like, you won't go down the right path, right? If for some reason he thinks that this is cheaper, he's going to go this way first, which is wrong. And even worse is if there is a really fast path here, i.e. a bus, but he does not accurately predict the fact that there's this fast path here, then he will never look at this node because this one looks nicer at like this location, like this particular location. And so I was trying to think about like, how are we going to solve that? And I think the plan is to basically try to greedily consume the entire bus network as fast as possible. So I was looking at like the number of bus nodes, and I was seeing that like there's maybe 6,000-ish, 5,000-ish bus nodes versus like 600,000 regular nodes. So if we could like walk the entire bus system, even if that's not the right answer, that should be relatively cheap to compute. And so I'm kind of thinking that we can do something like, if there's like a bus route over here, and then another bus route over here, and then there's like a train over here, and he gets us to this point, we might want to say like, let's say that there's also a bus that goes from here to here or something, right? If you were to say, which is the closest point to the final destination from this bus route here, it will say that this is too long, right? Like this is longer than this. So we need to find a way to make it so that we will actually take this like zigzaggy path. And so what I'm kind of thinking is, we'd say this distance is definitely shorter than this distance. So we'll take that first. And basically every time we see that we can get to a bus route faster than we can get to the final destination, then we use that as our heuristic. So the predicted cost for this node is actually going to be this distance instead of this distance. And then what I'm going to do is we're going to say that as soon as we hit this once, we're going to like kind of like explore. We're going to have all of the bus stops that it connects to available. But now we will no longer use the distance to this trip as something that we plan, because we've already got onto that bus somehow. We already know that we can get to that bus. And then we can do something like, well, from this node now, it's very close to this bus route. And so now this bus will predict this before we predict this distance, because this is shorter than this. And then we'll like consume this whole bus route too. And so I'm kind of thinking like that if we try that and we cascade that effect, our heuristic will then guide us in the right direction. And then when we predict the actual cost of this, we will say like, this took us like n amount of time to take the bus to this distance. And so we'll be able to say like the score, we'll be able to accurately say like real scores and predicted scores that should hopefully guide us in the right direction. We have not really hooked up the transit times here yet. So we're gonna have to do that. We're gonna have to say like, get trip schedules. We haven't done that. And we're also going to have to change the unit of our movement from distance to time. So right now we kind of say that everything works in distance units, but the bus schedules are in time units. So we're gonna have to like say like we walk at like n speed, and we can multiply that speed by how far we walk, and then we will get like a unit that is consistent between both buses and walking. And then we were also going to have to track the fact that we have like this ability to say that like, you know, I can like look at I can say like, I don't want to walk down alleys, right? So if I say, I look at these alleys and I color them all red, and then I say like the cost of this thing is going to be like 1.5 or something. You know, this will mean maybe coloring them red was a bad idea because our path planner is red, so we'll color it green so that the red-green color line people are in trouble. Unfortunately, my bad. But basically see like the path says here that I'm going to go like down, then right, then up, because he knows that I don't want to walk along this green line. And we do that by adjusting the like, we pretend that alleys are like longer than they actually are. And so we have to be careful here because the bus scheduling time is going to be related to like real time, not like this weird path planner cost adjusted time. So we're going to have to store like the actual speed that it takes us to get somewhere, as well as the like cost of getting there, which is like in speed units kind of, right? So I'll have to figure that all out. But step one, get the trip schedules. Step two is probably like track our like speeds and track our like movement speed. Then 3 would be to like hook up this like path planner stuff. I don't know how fast we're gonna get through all this. I think that just the fact that I spent 10 minutes explaining this means that the fact like maybe we're not gonna get all the way through it. But we'll see how far good. We'll see how far good. Let's just see what happens. But the easiest thing to do is get the trip schedules. So right now we kind of have the concept of like bus routes, not bus trips. So a route is like the bus number 25 goes down 25th Street, right? That's a route. But the bus 25 will go down 25th Street once at midnight, once at 1 o'clock, once at 2 o'clock, once at 3 o'clock. And each of those are trips. So we're going to have to like collect that data somehow. What we have is we have these text files in Google Transit. These came from like TransLink data directly. And in here, there's like this like trips thing, right? And so this has every single time that any bus will stop at any bus stop. And we're gonna have to like collect all of these, I guess. I guess. And we're probably gonna have to send every single trip to the client, probably for it to like successfully path plan. So what we do is we take like this like CSV that's given to us by TransLink, and we like stick it into like this SQLite database so that we can like easily do queries on it. Because like SQLite can like auto import a CSV like that. And I guess instead of thinking in routes, we will just think in trips now. I think that probably makes sense. So here we say get all stops, and this gives us a bunch of routes. And instead, I think we're just going to say give us a bunch of trips, please. Let's give us a bunch of trips. And each trip is going to probably have to tell us something about like, here, well, let's see. I guess we also are going, we want, we have stuff in here like give me the name of the bus, which is going to be useful for saying like, I want to walk this way and then get on this bus. Like when you give instructions, you don't say like, go to this GPS coordinate. You say like, get on the number 25. And so I guess we probably want like, we still want route info, but maybe the path is just not tied to it. And maybe the stop IDs aren't tied to it anymore. We just say that routes have names, and then we kind of have like this separate concept of trips. And the trips have paths and stop IDs. Great. And here we kind of hard code. Here we have both the path and the stop IDs, but that doesn't really make sense too much either, because each trip is going to use the same stops. Stops are consistent forever. And we were kind of like packing these all into one thing, so we were only ever looking at the stops once per trip, but now it's no longer true. So probably we're going to want like stops as well to be like its own thing, I guess. And he's going to have like points and IDs, I guess. This makes sense. Then our trip path will be just a list of stop IDs. Okay. Seems reasonable. Seems reasonable. And then the routes are going to be attached to... Trips are going to be attached to routes. So we kind of like throw this in here like this. And then our routes don't like have paths anymore, I guess. That feels right to me. Trip info is going to have to be deinitted, I guess. It's going to be like free the stop IDs. And then this is also going to have to be deinitted, and it's going to be like, I want to free these points. I guess. I don't know. And also the IDs, I guess. Okay. Okay, so now, our SQL queries. What are we going to do here? So before we were saying, like, get all stops, I guess we're not going to do this anymore. We're going to say, like, maybe, like, well, we can still say get all stops, but doing them by route doesn't make sense. Instead, I guess this just becomes, like, select stop ID. Well, let's see. Select, it's basically this, get stops, but get stops is not going to take a route input anymore. So he's not even going to try to like, he's not going to try to correlate trips at all. Not at all. So maybe, let me think about how I want to do this. Let me think about this. So I think we still want to call this get stops. And he's probably going to take an allocator in. He's probably going to make some sort of SQL statement. But now he's kind of just looking at the stops table directly. So there's stops and stop times and trips and routes. Stops, I think, is what we care about right now. I think. Yeah. Which is kind of all this is. Then we're going to like, well, there's nothing to bind here. We are just going to say, hey, we have this like return thing. Oh, we already had this stop sequence thing, which I guess is what we wanted. So this stops goes away and we just oh no, I lied. This is not a stop sequence. It sounds the same thing, but a stop sequence kind of implies that it is a trip, right? That we're going through these things in a order. This is an unordered list of all stops. So we're just going to call this a stops. And we are just going to kind of like, I guess we are saying that we return points and IDs separately. So this concept of having both ret points and ret IDs does make sense. And we are going to loop through the SQLite return and see what happens. So we are going to get the longitude, the latitude, and the stop ID. And we'll append those things. Oh, nice. Okay. So this gets us the stops, which means this get stops gets kind of commented out because this is no longer like, or maybe not commented out. And we call this like get trips. And this will return us a trip info. And I don't know what this does yet. So the way that trips are kind of manifested, I guess manifest is probably not the right word, but if you look at like the trips database, it doesn't actually tell you that much. Because these don't tell us like which stops it stops at which times. It just kind of tells us like, I don't even know. It doesn't really, there's some information here for sure, like bikes allowed, wheelchair accessible. I guess the block ID and shape ID are changing here a lot. But none of these are really something we use. What we actually care about is this stop times thing, where stop times uses a trip ID, and given that trip ID tells us which bus stop we stop at, as well as like the order that we stop at it, as well as like arrival and departure time. Okay. Which interestingly could be different. It looks a lot like they're very often the same, but we should actually keep track of that. That's an important thing to be aware of. So here, when we're trying to get a trip, we are going to get the stop ID. We don't need the stop like location anymore. We are going to get the stop ID and probably the stop times departure time. We'll maybe throw like fix me on here and like track arrival time as well. But I'm not going to do that yet. Okay. So we look at the stop ID and the departure time. And I guess, do we need a trip ID? I don't think we do. I don't think we need to track which trip this is. But we do want to know which route it is attached to. So here we want trips route ID. But even then, get trips. So we're trying to get all of our trips. So it's almost like we want them to be grouped in some way. If we were to try to get all trips at once, we're going to want to like iterate by trip. Let me think about this for a second. Does it make sense for us to return the route ID for every single row in this column or row in this retrieval? Maybe not, right? Maybe that doesn't make sense. Maybe it makes sense to kind of do these like individually. I'm not really sure. Let's can we SQLite browser test EV? I think is what it's called. I know that you can like kind of group things and such, but I don't really know how I want to do that. So let's start here. We want to like select this from stop times. Like let's just start there. This does give us a stop ID and a departure time. Great, but it doesn't tell us which trip it is. So we need to say, let's also get stop times trip ID. Okay. This makes sense as well. Okay. Then maybe we do something like, can we say like group by trip ID? Like, what does that do? So this returns me, I guess I almost want to like group by trip ID. Then I want to like sort by the stop sequence. Like this. I don't know how that's gonna like fuck shit up, to be honest. And let's actually like show the stop sequence as well. Okay, so I almost want this to be like order by, can I order by like a pair of things? Right, so can I say like, I want to order you by first by trip ID, then by stop sequence? If I say like, trip ID as integer, and then like kind of like slap this as a tuple. Does that do what I want? No. Row value misused. Fills in by time based off some distance from your position and your speed to get there. Would that exclude a bunch? That might help. I think that I want to do that like client side though. I think I want to like get all the stuff first, send it all to the client, and let the client decide how it wants to do that, if that makes sense. So first I want to get everything. Can we like SQLite order by multiple columns? Order by coalesce. That is what I want, I guess. Sure. So this starts by trip ID. He is fucking lexigraphically sorting the stop ID still though, which is or the stop sequence, which is fucking annoying because I said cast. Coalesce returns first non-null argument. Oh, maybe that's not what I want. Maybe I should have read farther. Can I like order by 2 columns? Oh, is it just no brackets? Order by comma comma? Order by this, that? Maybe that's fine. There we go. Hell yeah, that's what I want. Okay, so now we can get all of these stop sequences by trip ID, and if we just kind of iterate these if we iterate this, and basically every time we see a new trip ID, we like consider it a new entry, this should just get us like every single trip in sequence, which is great. So we'll start there. So it's like this. Stop sequence. I think we just trust it that it's right. So we kind of select this from stop times, order by, cast this, and cast that. All right. Now we say that this is get trips. We don't have anything to bind here, which means that we don't take in the root ID here. Then we say we are returning I guess for now we will store the trip ID here, and we will later construct a mapping from trip ID to root ID. I think that will be the easiest way to do this. Yes. So we are going to return an array of trip infos, I guess. And we'll just say our return is an array list of trip info. And what are we going to do? We're going to say we're going to extract. What the fuck did I just do? Jesus. I already forgot what's in trip info. It's got stop IDs and trip ID, which makes sense. I guess we are kind of claiming also stop times is an important aspect of this. And how do we want to process this thing? I guess for now, we're just going to store the actual string of the time, but we will have to figure out like a better format for it later. I just don't want to think about it quite this second, like right this second. I'd rather kind of get something working a little bit and then iterate. Iterate. So here we are extracting stop ID, which is going to be an integer. So we can use SQLite 3 column int64 from the statement. This is going to be the stop ID. Then we have the extract column text, column 1. Is going to return error no time. There's no time, like the present. And this is stop departure time. And then we get the trip ID. which is column 3. Okay, or column 2, sorry. Okay, so now we're going to say this is like this trip ID, and we're going to say like trip ID is equal to -1, right? And we'll say here, if trip ID is not equal to this trip ID, we are initializing like this is a new trip. This is a new trip that we have to handle. So trip ID is equal to this trip ID. And I guess we'll kind of say that we have like this trip stops is an array list of int64s, right? Then we defer this trip stops deinit. And then we also are going to have this trip stop times, I assume. Yeah, this trip stop times. This trip stop times. Boom, boom. And then this is a const-u8. Gross. This is nasty. Like looking at like the amount of allocations in here, but like what you gonna do? What you gonna do? If you need the stuff, you need the stuff. Okay, so here, if we have a new trip ID, we're gonna push the previous one. So we're gonna convert this to own slice. And we are going to say that this is the stops. We have the times is this trip times. And then we say ret.append trip ID is equal to trip ID, which means that this kind of has to get done at the end here. Because this is like for the trip that we used to be working on, right? Yep. This makes sense. So we have the trip ID. I don't know what this was called. Trip ID stops equals stops times equal times, I guess. I don't know. I don't remember what this all called. Again, stop ID is stop times. Okay. And then then after that, we can push the stuff to our current. So we say this trip stops, append stop ID, and this trip stop times, append this trip ID, or stop times, oops, this. Is there anything else we need? No, I don't think so. Okay. So at the end of this, we didn't do departure time. Oh, right, because we can't depend. This is departure time. My bad. My bad. Okay. And then we return ret. Own slice. Boom. Boom. That seems like maybe reasonable. We do have to call this thing to figure out if it works, though. Let's kind of... Oh, the nice. There's already a main in here. Perfect. Let's say get trips. We'll just kind of see what this looks like. Let's just see what happens, you know? Zig run, zig source bus db. C import failed because we need to link libc. I'm sure we need a bunch of other stuff. Extract column text didn't work. Probably because I didn't pass in an allocator. That would do it. He's still mad. Because this is try. Stop times expected to const u8 found const u8 or array of u8s. So that's kind of interesting. That is true that he does need to be a double array. Error unit is ignored at 211. Why did I write defer there? I tried to write try. I don't know what the fuck I was smoking. Smoking crack. Okay. Now, this is taking like a fucking year. But it's doing something, maybe. Maybe we will print the trip ID as we go. Just so that we can see some form of progress. And it does seem like this is just a lot of stuff. Now I wonder whose fault this is. Let's try release small or something, just like see if it like goes way faster. There, okay. So that did go way faster, and we are seeing trips with IDs and with stop IDs and stop times in there. So I think we're probably chilling. I think we're chilling. Let's also try calling get stops, because we did change that. And let's just kind of like see that that looks semi-sane as well. Failed to prepare get stop point statement, so it's not okay. He is not happy. That is true because I did just write select. And that is happy not to. Okay. Chillin'. Chillin'. Now, let's not worry about tying back to roots right now, however nice that would be. And let's try to integrate this into like the return data. So what are we going to return here? I haven't really thought about that yet. Like, what is the client going to look at? He needs this tasty data. So we kind of return like a blob of binary data as well as some metadata. I think the trips are going to be, let's put the trips, so we already in the binary data, we store all of the points for all of our OpenStreetMap nodes, and we store all of the connections between those points. Those already have like a defined format. So I think that we can kind of just continue to use that. And we already have done that for the bus lookup for like the routes in what we have already. We just have to basically replace whatever we were doing with the route stuff with split, stop, and trip stuff. split stuff. And then I think that we will track the times probably in metadata, probably. But we'll figure that out in a second. So let's see. So here somewhere we get the stuff, right? Okay, so const stops is equal to try bus db get stops. Chillin'. Const trips is equal to try bus db get trips. Also chillin'. It's so simple when you put it this way. Here we need to do like for trips, trip. And then what is this, like trip dnit? And then defer alloc free trips. There you go. I guess we'll do it this way. Fuck it. There we go. Okay. So now, instead of iterating routes, we can just iterate our stop IDs. So we don't even have to track like scene nodes or anything. We can just kind of like say like for stops. We push a node. So this is going to be stop ID, which we have lost, I guess. I think, because it's not auto-completing here. So let's kind of go back to stops, and let's double check. Get stops, stops. Ah. I see. We have them split for some reason. I don't remember what reason, but we will find that out very quickly. So for 0 to stops IDs len I, const stop ID is equal to stops IDs I, and const stop look is stops points I. I'm sure there's a reason for this, but I don't remember what it is. Boom, boom. All right. Now we have all of the stops pushed, and now we can iterate for trips. So for trips, we have trip. And we're not doing this like, we're not doing this string data stuff. We are not appending tags to these things. We're just going to put the fucking thing in there. So this is push GTFS way trip stop IDs. Okay. Sure. And then I guess that should be everything that we need in order to render the like bus locations. Then here is us like trying to generate connections from the node graph to the bus stops. Okay. That makes sense. So here we can kind of look at I guess we want to do this for each stop now. So for stops, for 0 stops IDs len, I. We have const stop ID is stops IDs I, and const stop lock is stops location points I. Okay. We're chilling there. And then all of this stuff where we're trying to use latitude is stop lock. Stop it and lock it, you know? And then this is stop lock as well. Item key pointer, this becomes stop ID. And then I think it's fine. So I think that if we did everything right, we should see fuck. Hold on. We should see fuck. Maybe I should wait like 3 seconds before assuming that it works. Where is this coming from? Bus DB. Get all stops. This shouldn't even be used anymore. We're not using this anymore. Make site. dinit expects an allocator probably. Okay. What we should see is we should see that all of the trips are still drawn, but before we were drawing like one route at a time, here we're gonna see like the same fucking route drawn like 40 times. It would be my guess. But I guess we won't really like see that visibly because they'll all be drawn perfectly on top of each other. I guess there's a good chance that when we process this data on the other side, we're gonna crash. Actually, that's actually very likely. But we'll see. We will see. That's a lot of leakies. A lot of leakies. Could you stop, sir? Sir, could you stop? Thank you. Thank you very much. That's very kind of you. Okay, so now we just want to run the app, I guess, and just fucking see what happens. Oh, that's a really surprisingly good sign. So we do see like a bigger nested web of shit here than we used to see, which is kind of an indicator that this is working. The fact that we still see blue lines here is also very good. Yeah, it's just very likely now that we're drawing like a lot too many lines. Okay, cool. So let's attach. How do we want to represent time here? Like seconds since midnight, I guess. It's kind of weird that we don't really have this concept of like day. Like, why is that? Like, how do we know what day these things are running? You know? I guess the assumption, no, I know for sure that we have different stop times on different days, but I'm just not going to worry about that right now because we are not going to get far enough today anyways, so trying to tack on more confusing information is not going to help me. So let's for now just say that we will represent time as like number of seconds since midnight. Okay? In which case, when we pull this stuff out, we can say that the stop times, we're going to store these as, you know, I64s, U64s. I mean, how many seconds are there in a day? How many seconds are there in a day? 24 times 60 times 60. 86,000. So U32. And then when we push this thing in, we're going to have to like calculate this. So we're going to do like, here are stop times that we previously said were strings. We are going to list as, I guess, U32s. Okay. Then here we're going to have to like calculate our departure time. So we're going to do like departure time stood mem split scalar. We are going to split the scalar of a colon. Yes. And we are going to look at the departure time. Boom. I think that's the right order. Needle haystack. Buffer delimiter. Yes. Okay. So we'll say time iterator. Okay. We're going to say time it's var departure time. We'll call this departure time string. And then we'll say var departure time is equal to time it next, or else return error no hours. Right? We'll call this const hours s, minutes s, and seconds s. No minutes, no hours. Okay. Hours is the hours stood format parse int of hours s in base 10. So we'll call this U32 hours s base 10. No seconds. That's a good point. Thank you. And this is going to be tried, I think. Is this parse int error? Yep. I guess we'll say catch return error invalid hours. I don't really care about like, I want like a better error there. Minutes takes minutes s, invalid minutes, and same for seconds. Yep. Invalid seconds. All right, and then we can say what? The like const departure time is equal to hours times 60 times 60 is right number of hours. I'm assuming this is 24-hour, but I actually didn't check that. Stop times. Yep, 24-hour clock, sick. So hours times 60, so 24 hours times 60 minutes per hour times 60 seconds per minute, plus minutes times 60 plus seconds. Sure, that doesn't seem crazy. Yeah, sure. Oops, we are missing last trip. I just realized because we are only pushing when we see a new one, but I'm not going to deal with that right this second. And let's just, I guess we should maybe run main here and just kind of see if we get something sane. So can we zig run? Let's just kind of see what happens. Invalid hours. It's no bueno. Okay. So what is happening here? Print hours. Hours s. What are we seeing here? What are we seeing here? What are we seeing here? 5. So what the fuck is the problem? Maybe we need to trim. Like stood mem trim hours s. This is trimming a U8 with stood ASCII whitespace, which is going to be a bunch of whitespace characters. Maybe we'll do this. Here we'll s hours minutes, s hours seconds. We'll see. Array literals. These need to be like ampersands here probably. Okay. Let's see if that fixes anything. Good sign that it's not crashing. Okay, yeah, so this is working now. This is working now. Now, I don't have any idea if they're correct, but fuck it. You know? We don't consider such trivial details around here for like things like if our code works, right? We don't really care. Okay, so for each trip, I think that as we push the trips, we will just kind of insert those into the metadata. So here we'll kind of say like bus trip times. Oh, wait. This is going to be what? Like an array of like an array of U32s. Right? So this is going to be indexed by trip ID, then trip segment, I guess we'll call it. Which we don't have to tie these back to stops because those are already tied back to stops in the like how do I call this? In like the binary data. That's already been handled. Okay. Bus trip times is equal to, I don't know, something. Set trip times. And how do we do that? How do we do that? So we have trips. And what do our trips look like again? They have stop IDs and stop times. Oh, sick. So we can just copy the stop times into an array that doesn't exist yet. So here we'll just say like trip stop times is stood array list of U32 slices. Defer trip stop times unit. Boom. Okay. And then when we, for each trip that we push, we say try trip stop times append trip dot stop times. Okay. And then now we can go down here and when we write the metadata, we just say trip stop times items. Sounds right. Sounds right. We will see. So now what we should expect to see is that the metadata that we get associated with this thing, when we look at it, it should have a bunch of numbers in it in a double nested array. That's what we're hoping for. That's what we're hoping for. And I guess from there, we're ready to start like hooking up to the path planner. I guess. Maybe what we'll do first is maybe we will maybe try to visualize this stuff in some way. So maybe like throw on like some sliders to look at when trips start and end or something. I don't know yet. We'll see. This is taking a long. Okay, so he finished writing, and can we like just kill him because it doesn't really matter at this point. Let's run our app. And we can kind of just see now, when we look at the network traffic, we can look at the JSON, we can look at the response. In fact, we'll just open this in a new fucking, can I open in new tab? Okay, bus trip times. Oh, it hurts. Oh, geez, my Firefox is dying from that. Which I guess probably makes sense. First of all, how fucking big is this JSON blob? Is it like fucking like disgusting? 15 megs, that's pretty funny. That's probably, a lot of that is probably the trip times, to be honest. But that's okay. You know, we'll probably fix that later. Maybe it makes sense to shove it in the binary data or something, but... what was I trying to do? Map metadata. What was it called? Map data, sorry, map data. And then let's look at like, maybe can we look at like a bus stop times 0, 0 or something just to see. Okay, that doesn't exist. Bus stop times 0. Still doesn't exist. What was it supposed to be? Bus trip times, that's why. Bus trip times. Okay. Interesting. So 1 has something. Trip 0 has no stop times, which is weird, but I guess that's because we pushed an empty array on the first iteration of our database lookup. Right, like here we did if trip ID is not equal to this, then we push this thing. But this happens once on like our first iteration, which is like a fucking problem. So if trip ID is not equal to -1, then we do this. Okay, let's try making the site again. Make the site again, please, sir. The fact that these are increasing with time is a really good sign, by the way. That means it's very likely that we're getting this right. Because it means that the order that the bus stops should increase in time, and these are increasing in, you know, units of seconds. Seems about right. Seems about right. All right. All right, so now if we look at bus trip times 0, it exists. Hell yeah, baby. Okay, so now let's try to visualize this in some way, shape, or form. So I wonder if we can say, like, show me buses that are, like, within some certain time range, right? Let's try that. So we'll say, like, visualize trip times. So that I don't have to say question mark, question mark, question mark. I know that it's 52 minutes into stream. 52 minutes into stream. The faster the transport means greater potential savings, making sense of searching for buses outside of where you would search for walking routes, where the search. Yeah, so I think that's why I'm kind of saying that, like, here, my plan is to basically try to force the A* algorithm to prioritize just getting to the fucking bus stop. Counts as negative cost. I don't think anything is negative cost. Nothing goes, like, back in time. But I think it's sub 1.0 cost. But if we convert all the cost units to, if we, yeah, it'll be, we'll see when we get there. I'm not really sure. The time unit might kind of like fuck this shit up. I don't know. We'll see. You can tell that I haven't like I don't have it like perfectly in my head because I'm just like, stuff might get fucked. I don't know. It's like, sound like a fucking idiot. But it's okay because that's the process. You discover how things should be by starting to implement them. And by you, I mean me. Maybe other people are better at, you know, writing documents. Like, my coworker worked at this place, or not my coworker worked at, my ex-coworker, which makes it sound like we broke up. We didn't really break up. We just don't work together anymore. Someone I know ended up working at this place where they had to write like design documents before doing any ticket. And I'm like, I feel like I like literally couldn't function there. Like, for me to write a design document, I would just do it. And then I would submit the design document and they'd be like, okay. And then I'd be like, okay, the PR is ready to go. But I'm sure that there are people that are better in working in that environment where you can like, you have to think ahead. I just can't do it. I just have to like fucking start. Which is why I sound like a fucking idiot. Okay, let's try to visualize these things. So let's go into like the MGUI version of the app. And we'll say native Guofua is where we live. And let's try to do something like maybe set a range. Because IMGUI have like a range widget. Somebody asks, do you have one? In 2014. They have slider 2. Nice, that's what I want. That is what I want, slider 2. So somewhere in here, I'm gonna be like, yo, I want 2 floats, 2 ints, 2 floats, 2 ints. We're working in the units of seconds. And I want this to be like the range, the integer range, the bus time range. And I want this to give like maybe here we're gonna store the bus time range like this, and it's gonna be 2 floats, right? And the initial values are gonna be from like the beginning of the day to the end of the day. So 24 times 60 times 60, right? This is the initial range. Then here we will say self time range. We pass in here. And we have min and maximum values. So the minimum value here is 0, and the maximum value is 24 times 60 times 60. What else goes in here? Format, I guess, is just %d. I guess. Vmin, Vmax format flags. Vmin, Vmax format flags. Okay, that seems good. And if we do this, like nothing happens for now, that's fine. He's mad about time range being floats. That makes sense. Let's make him some ints. And let's just see what happens. Optimize, release, small is what we decided was the fastest. And by decided, I mean somebody said it and I believed them. It must be fun being good at programming, just spending a bunch of time programming all sorts of shit and being actually... Yeah, dude, it's so fun. It's so fun, just like... It really feels like you're a fucking wizard. Like, that's how it feels to me, is that, like, just... You, like, think of a thing, and then, like, you can make the thing happen, and that's so fucking cool. Like, that's actually so fucking cool. And I think you'll get there. You'll get there, eventually. Takes some practice and time, but... And I think, like, you don't even have to be that good. Like, you just have to, like, have the motivation to just, like, you know, force it on yourself. How do I, like, move this slider in a way that it, like, doesn't jump by, like, 10,000 at a time? That's fucking annoying, but maybe this will be enough for us to filter. Like, we should at least be able to filter, like, the nighttime buses with this, so let's try that for now. I feel that way all the time, especially in a game where you're making a wizard. Yeah. Okay. So here we'll say, I don't know, time range is time range. I think that this mechanism of us like returning a thing that changed, as like an optional thing is like maybe kind of stupid. Like maybe we should just be like working directly with the app here, but whatever, it's fine. It's fine. So here we can say if we got some time range, we will set the time range. So do we have to do anything there? If we're just like setting this like as like a thing that we're viewing, then that probably just gets stuck as I think we just say app time range equals range. That's probably fine. Maybe we'll in the app, I guess we're probably gonna do like we'll call this like bus viz start viz range transit viz range start is equal to range 0. This probably makes sense here like this. Yeah. And this is probably going to be int cast almost certainly, because these aren't going to be c ints in that world. These are going to be U32s on the other side. Do you think the software program you do is more like using raw materials and Lego blocks? I mean everything's Lego blocks, right? I think like you get down to like the fundamentals of the universe and you're still working with Lego blocks, right? So like I think nothing, it's rare, very, very rare, I think, to make something like completely new. So I don't know. I think everything's like Lego. What do we call this shit? Time viz range. This is a struct that has like a start as U32 and an end as a U32. And then we say time viz range is a time viz range, and his initial values, I guess we're just gonna start like equals 0 and equals from 60 times 60. And we can like maybe stop fixing on here and be like 24 times 60 times 60 is in a lot of spots. Maybe that's fine, maybe it's not. I don't fucking know, man. Time viz versus transit viz range. Okay, what am I doing now? What am I doing now? I am trying to say transit vis range is equal to, you know, default values, which is fine. I guess we should just do that here, to be honest. This is default, please. Thank you. And then does this not, this does exist now? And then what's the last piece here? The last piece is on render. We need to basically rip through the metadata of trips here and I guess limit who makes this transit EBO? This guy. So here we kind of say like rip me through transit neighbors. I don't think that's what I want. Num points get transit neighbors. Yeah, this isn't really what I want. This is like kind of debugging for something else. This can go away, to be honest. To be honest, we don't need this anymore. Imposter syndrome humps us all. Yeah, dude, I think it's super fucking common. Super common. Yeah, it sucks. But also, you just have to inflate your ego to like an unreasonable point, and then you believe that you can do no wrong, and that fixes it. And causes all sorts of other problems. But it fixes that particular one. Okay. So I guess maybe actually I've changed my mind. I've changed my mind a little bit. I'm gonna make it so that when we're gonna have a function. Where was this in Glufwo, native Glufwo? Instead of doing this directly, we're gonna say app.update time range. And we're gonna say, here is the start, and here's the end. And that will allow us to do kind of some initial work to update the display data at this point in time. Which means that now in the app, I'm going to undo that transit EBO. I'm going to leave this element buffer here, but I'm only going to populate it on, hold on. Thinking. I'm only going to populate it when somebody asks us to change the range. I guess initially we kind of want to show everything. So we can kind of do something that's like ret.update time range from 0 to 60 times 10, 20, 24 times 24, and write a fix me, you know, hours, seconds. Okay. Okay, and then we need to make this update time range thing. So function update transit or update time range is going to take a start u32 and end u32 and return void. He's going to look at self and he's going to be like self transit EBO is going to be like bound as like a GL element buffer. So we're going to say, hey, I'm working with this shit, baby. And I want to like put some data in here. And I don't really know, or it's like GL buffer data. And we're going to be like, we're uploading elements, baby. We can put this stuff in here. And then we have a pointer and a length. So the pointer is going to be buff.items, probably. And the length is going to be buff items len times 4, probably. I don't fucking know. And the usage is going to be like GL static draw. Boom. Now we have to make buff. Var buff is a stood array list of element indices. So we need to like use our own allocator, I guess. Right? Okay, then what? We're gonna like iterate all trips, bus trip times. So this is gonna be like the trip and the trip ID. Right? And we're gonna like do something with it. We're gonna be like if for trip time, if time is greater than start and time is less than end, we say that this is a good fucking trip. And then we break. So if it's a good trip, we look at like self ways. We want to look at like the metadata. Our metadata has like a bus way start index. Right. So we have like a bucket of ways. And the way index, the bus index are now trips. Or the bus ways are now trips. So if we go like we can call this like const bus ways is the self ways from here onwards. And then we can look at bus ways at trip ID. Hell yeah, that sounds right. That sounds right to me. Maybe calling it IDX is going to be less confusing because later there's going to be trip IDs, which are different than trip indexes. Probably, maybe. I don't fucking know yet. And we are just going to push the indexes associated with this. So can we, what is a bus ways here? Self ways like this, I guess. And then here, I guess we will be like, I'm assuming this returns me a bunch of node IDs. Yeah, so we can say like, buff append slice pointer cast this shit, which is a little bad, but you know, shut the fuck up. I can do what I want. Okay. Error out of memory. Expected type void, so this has to be failable. And then then we also have to append a max int, because this says to OpenGL, hey, this is going to be like a different fucking line now. Start a new line, please, sir. And I think this is fine. So I think that this will do what I want. Then here we are already drawing that thing as a line strip, so I think it should be fine, to be honest. We'll see. It's not fine. It's never fine. But that's also okay. We'll fix it. Native glyphua. And then where was the, here, update time range, we'll try here. And I think we're chilling now. Maybe. Maybe not, but maybe. Okay, so the easy check here is if we just make start bigger than end, we should see everything go away. In fact, we already see everything go away. So this is just clearly not fucking working, right? So that's not good, right? This should show something. So that's very bad. Very bad for us indeed. So why the fuck? So that must mean that this isn't doing what I want it to do. Oh, it's because we don't update transit EBOLen. Because he tries to draw some amount of elements, but we don't know how many elements those are to draw, so we have to say buff items len. Fuck! Maybe again? Maybe this time? Dude, computers are so fucking fast. Like, the fact that this works is, like, astounding to me. Just, like, we're, like, fucking ripping all the bus routes in Vancouver. Just, like, fucking, like, in, like, milliseconds? Like, that's crazy. That's fucked. Okay, let's see if we can, like, kind of force it to show me, like, night buses. Okay, so we can see that, like, this bus, whatever this bus is, goes away after a certain time. So that's a good sign. It does seem like it's kind of working to some extent. Which is cool. Which is very cool. So this bus must ends at like 11 or something. And I mean, again, like this, we didn't need this to be perfect. We just need to be good enough to prove to us that we have trip times that we can work with. Right, so you can kind of see like stuff kind of like slowly fading in and out. So that's really good. Really good. Really good. All right. Now what? Now what? I guess we need to look up track arrival time at each node when walking. I guess that's fair. I guess it does seem like a reasonable next step. The next step is like we leave at a certain time. And then we should know what time we get to a location. Yeah, let's do that. Let's do that. So I guess the starting point here is that we need to say what time we are starting to walk at. So let's do in native Glyphwa, we'll do a like path start time. And this is going to be an integer. Okay. Here, I guess we're going to stash like path start time as an i32 is, or a c int is equal to 0. We'll pretend, you know, by default, we'll start at midnight. And we will just kind of like draw that somewhere. So wherever the fuck we were saying like bus time range, yeah, I guess we just say like, I guess a slider is fine. Maybe a text, I kind of like an input here, to be honest. We'll say path start time. And we'll put in seconds since midnight. This is going to get the, what the fuck, time, path start time. Okay, and do I have like the same fucking like limits here? Step and step fast, I just won't put those. Fuck steps. And then flags, so this is like this. Boom. Okay, and then we kind of do the same shit where we're like, hey, if we see a path start time, we do something with it. And we'll say like app path start time is equal to t. Boom. Sure. Path start time. And this is going to be a U32, which means that here we have to int cast, which is fine. Does make me really want to get back into my Zig project. Hell yeah. Dude, programming's so fun. Super fun. Okay. So now we have this path start time that we update. And when we start the path planner, I guess we want to like take in that thing, I guess. Seems reasonable. I guess we also need to take in like a walk speed, huh? Or like movement speed. As a float, seems reasonable. So we also need like movement speed. Just kind of like boom, boom, movement speed. Like this, boom, 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 boom. We need a movement speed over here. Movement speed as a F32, and we need another one up here. Also, to search n times as far based on speed of each travel type, maybe that value is single multiplier. Yeah, so I think that what I'm going to do is I'm going to have presets for biking and walking and driving. No, I'm not going to have a preset for driving because I don't have a car, but I'll have presets for biking and walking. And then those presets will have like defined approximate speeds. But for now, I'll just punch them in because fuck it. This isn't in cast anymore. This just gets assigned like this. We have a movement speed here as an F32 equals to, I don't know, how fast do people walk? What is the average walking speed? For most healthy, 3 miles per hour. 3 miles per hour in meters per second. 1.3. And I guess we kind of duplicate that here, which is kind of like fix me duped defaults. That's fine. You do 4. I do like to walk a little quick, but there are people that fucking rip past me too, though. 3 is for like boomer. Oh, I see. Well, we'll fix it later. I don't really care, to be honest, because eventually I'll have to like actually like, I'm probably gonna go outside and like actually time myself at some point. But for now we do this. Okay, so when we initialize our path planner now, we just need to check on self path start time and self movement speed. He doesn't compile, of course not, because it's in the path planner. These are unused. So here we'll just kind of write those things down. So we'll say path start time is equal to 2, and the movement speed is an F32. Boom. Path start time is not used because we didn't write those things down. That's true. Path start time and movement speed is movement speed. Boom. Movement speed there, he's mad because it was an inch, not F32, and native glyphful 583. Because this should be IG input float. That's fair. And here he actually wants a format thing, which I think was on this argument. But I don't remember. Boom, 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 boom. All right. So now we have a movement speed, path start time, sick. And so here, I mean, we have nothing to prove that this is doing anything, but eventually we will. So I think what we want to start with is let's just kind of log in the GUI, like how long it took us to get somewhere. I think that makes sense. So here we'll be like, hey, we're going to push trip time, set trip time. And this is just going to take in like one float, probably. Which is going to be in seconds, I guess. Sure. So we'll just put like a little S in there so that we know. In appzig, we are going to run the path planner. So we're going to like run this thing. And if we got a path, then we are going to write down, I guess, pp run. So I guess I kind of like the model here is that this gives us the path, but kind of we have like internal state for like debug info. So I guess it's kind of fair for us to just like fucking look at. Like, well, he only calculates the time for the, like, how do I say this? Do I want to store the time that it took to run that path? I think probably not, actually. I think probably I want that to be returned as part of the return because like the way we like calculate the path is we do one backtrack at the very end. And so that one backtrack here, reconstruct path, he's just gonna have to return like a new thing. So we're gonna have to be like const ret or planned path. Give me a struct. He's gonna have like his, you know, node ID path, but he's also gonna have like time for now. Consider an upper speed to define dual logistics. I think it'll probably be fine without. I think, but we'll see. Because like I do want to be able to like support like driving, right? Or biking. There's no reason that I couldn't bike to the bus, right? And so I should support that. Okay, so I think what I'm going to do is each node, as I walk, I'm going to, I guess as we reconstruct the path for now. This is not how we're going to do it later, so maybe this is a silly way, but I was going to say we could, as we backtrack, calculate the distance and multiply that by the walking speed. But I want to make sure that like as we're moving, we know how long it took us to get to an individual node. And so there's a couple places we could track that. One is we have these like global arrays for each node in the graph. Like this is like the best score of how we got there. And so it kind of makes sense for us to track along with the score, like the best, like the time taken, right? Now, the other option is that we kind of, as we put things into this like this queue of like items to process, we can kind of like store like ephemeral data in there. So we kind of store like F scores in there because like we don't need a globally available F score, right? We kind of just need like for this part of the search, we need to know this. And so maybe we'll store it here. That kind of feels like it makes more sense. And it means that like as things get pushed and popped from the search graph, like the search list, it means that we like use less memory overall because we will lose time taken for nodes that aren't at like the edge of the graph, which I think is totally fine. I think we'll find out later if this is a problem, but I think we're just gonna store it here. you can make each G-score be temporally based if you bake that, if you do the cost there, won't it implicitly bake that in? Yes, except for the fact that we have cost multipliers for like sidewalk. Sidewalk is better for, we say that like the score to walk on the sidewalk, we are willing to take a longer path if it means that we are walking a more preferable route, right? So if I say that I want to walk on the sidewalk, not the road, then it's going to not take the road, even though that's faster. So we need to store the scores separately still. So yeah, I think I'm just gonna start in here, which means that wherever we store, like here we need like time elapsed equals 0. We seed this with no time taken. It is true. When you start, you start. And when you end, you end. Then when we push this thing, we just have to figure out like this time elapsed is going to equal like the previous time elapsed plus the time it takes to travel the distance. So can we like const neighbor dist is equal to this, right? This gets like plus neighbor dist. And then here we're just gonna like prev time lapse plus neighbor dist times speed, movement speed. Okay, so now we are just missing prev time elapsed, which must come from like wherever the fuck we call update OSM neighbor. Update transit neighbor, we're gonna do this like differently, so I'm not really worried about like keeping those in sync right now. And here we have like a node that we popped, current node ID. So here I guess we'll just pass in like current node, I guess like current node ID dot time elapsed, which is like a funny, this shouldn't be called current node ID. It's actually kind of more like current node, but it used to be an ID. And so we've kind of like just kind of kept that naming, which is fucking stupid and funny. But what you gonna do? Fix it? No. Fuck no. Fuck. Crack me up sometimes. All right, missing field time elapsed. So this is 245. So here, I'm just gonna say that the time elapsed is gonna be prev time elapsed, I guess. And all right, fix me figure out bus schedule shit. Which means that this needs also prev time elapsed. That's enough 32. Boom. Bing, bang, boom. All right. So now at the end of all this, we should have a time that we can return to the caller, but we haven't done that yet. What will we laugh about at office parties if we fix it? Yeah, my office party of just me. That's like me on a Saturday night by myself with a Mickey. Just like pointing at like stupid code I wrote and then just laughing about it instead of fixing it. Okay, reconstruct path. This is the path is this, and then we're gonna return path is equal to path, and time is equal to current node ID time elapsed. Boom. Easy. Now this is gonna return, instead of this, it's gonna return a planned path. And this is, the planned path is where you go when you get pregnant by mistake. What is it? Planned Parenthood? Stupid fucking joke. Never mind. Pretend I didn't say it. I take it back. Pretend I didn't say anything. Okay. Then in the app, we just here say if we got a new path, it's new path dot path for the planned points, and then we just kind of say like GUI dot set trip time to new path elapsed new path dot hello. New path is a run. He returns a planned path. Oh, this has to be optional. Right. That makes sense. Which means that this now has a time. Yeah. optional type. Am I stupid? PP run. Oh, this did not return. I'm an idiot. This is like this before. So I don't really know why it wasn't working, the autocomplete, but I think it's fine. Okay, so now in Glufwa, native Glufwa, here we have to implement like pub export function set trip time, which takes in time s as a float and returns void. He's just gonna say like, hey, we have this like globals time, elapsed trip time is equal to time s or something. Var trip time is a float through 2 equals 0, and then we display this thing where we do like node ID. We just kind of slap this shit in here. Elapsed time is a float. And then we're gonna say trip time. Boom. There's like a there's 100% chance that this doesn't work, but I was gonna say there was a non-zero chance that it does work before, but now there's not because I fucked something up. In appzig 251. That's true. This should now be defer new path dinit, which kind of indicates that here planned path needs like a function dinit, which takes in like a planned path and an allocator, and it's like self path alloc free this thing. Boom, 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 boom. Dun, 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 dun. I wonder if the allocator should be passed in there. Yeah, okay, that seems fine. That seems kind of reasonable. All right. All right, fuck. No undefined symbol set trip time. Did I implement it wrong? Set trip time. Hub export function set trip time. Set trip time, man. Oh, it's in the no GUI version. Sure. Native no GUI, right? So we have to kind of stub this function out so that the linter doesn't like fuck itself. That's fair. That's fair. Give him a sec, he's thinking. All right. So now we have elapsed time 0.0, and if I start a path, it's doing something. Now, whether or not I think that this time is reasonable is hard to say. You guys, I don't know if you can even see it. It says like 422 seconds here to walk 2 blocks. That's absurd. Like, actually absurd. So, is it? That seems absurd to me. 422 over 60. Dude, 7 minutes? There's no fucking way. So, like, usually my metric is like 1 short block per minute is like about what I think is like if I'm going like kind of quick. So here, this should be like on the order of like 60. It's like about 3 times. So maybe I do walk a little fast though. So saying that this is 3 times or like 2.5 times what I think it should be, maybe that's not that crazy. In the UK, you don't have blocks? What? That's, I mean, you don't, what do you mean you don't have blocks? What does that mean? Hold on a second. Maps, google.com. Just let me make sure I'm not leaking my location. I'm not. You predate blocks, but like, surely you have like, oh, you just mean that they're not like on a grid. I see. I see. So they're not blocks. They're just like intersections is kind of your argument. That makes sense. I see. That's fair. Yeah, I guess we are very grid here. We are very grid. So yeah, I think that just kind of lines up with what you were saying. But like the walk speed I picked was just too low when I Googled it, but that's fine. Okay, so track arrival time at each node. Done. Now, what? Now we have the arrival time at each node, so we can use this information to try to decide the cost of getting on a particular trip. So here we're gonna say like this is at 01:29:50. We're gonna say like calculate trip costs based on time. I think that's reasonable. Which I guess kind of means that before we do that, though, we kind of need to update cost function to work in time units. Is that what I want? Let's think about this, actually. I think I want the heuristic to still be distance-based. Right? Because kind of what I said for that I want the heuristic algorithm to be is like, I want it to be that we just kind of like fucking straight line it at buses. But I guess when we get to the bus, its movement is going to be in time. So I guess we still do want to work in time because we need to track the time that the only metric of information that we have for how long it takes to get between stops is time. So we need to work in time units. We'll say that the bus time unit is like a 1.0 cost multiplier. And so we should work in time. We should work in time. So we're going to start with our, and so does the heuristic want to be in time units as well? I guess it does. I think everything wants to be in time here. So here we'll kind of say that this is like movement speed. Okay, so first let's kind of say that that's what we're doing, is we're working against time, which is what we wrote. So this is going to be self.movement speed here for the heuristic. And this tentative score is neighbor dist times self movement speed. That makes sense as well. Current score is already in time units, and we multiply node costs and turning costs here. Turning cost scores might have to be adjusted a little bit, but that's okay. I guess the turning cost is kind of like runtime inserted, so it's not the end of the world. Okay. Okay, sure. And now, I guess, since that was like a fucking like 3-second thing, we're just gonna say, we're gonna change this to work like appropriately pick trips based on time. Right, so we should be able to like get to a trip, and when we say get transit neighbors, we are going to update our transit neighbors, and we're going to have one neighbor per trip, which means that maybe my initial guess about the like 5,000 bus stops. Oh wait, that's fine. So we still get to a bus stop, and getting onto the bus stop is now going to be like, this is fucked up now, because initially it was that I had a bus stop, and I just wanted to get on the fucking stop. But now our edges between stops are not constant. I didn't really consider this up until now. So up until this point, we've kind of had the concept that like we have like spatial nodes on this graph, and they're connected via streets, right? And you can just like, if you are at this node, you have a neighboring node here. And you can just like get that node and then calculate the distance here, and that's like kind of like your cost for walking over there. But now with the concept of buses, you have like a stop here and a stop here, and it's not about this connection. It's about when a thing will come here and take me to here, which is kind of interesting. Did I swap out A star with a heuristic? A star involves a heuristic function. So the way A star works is there's like a real distance that it takes to get somewhere, as well as like a guess for each node, how you get to that place. So we're just kind of, we have to update like the heuristic function is what I'm calling, what they call in like Wikipedia the F score, which is like previously was straight line distance. But now I'm saying like straight line distance plus time, and we're gonna have to change it. We're gonna have to adjust it so that the heuristic kind of favors going to the bus. But I need to think about it a little bit more right now because there's something that I've missed here. It's almost like the concept of working in neighbor space for transit just doesn't make any sense. I thought it did before. And we did a bunch of work here to like get us set up for today by like saying that we have neighbors. but it's just wrong. It's just wrong. Instead, we want to do like, we are trying to get to trips. Trips is the unit that we care about. And so what do we do here? It's like we want like a list. We have a list of trips. And we know from our location that we are adjacent to some stop. Right? So we definitely want a stop to trip mapping. Right? And I'm trying to like imagine the search space that we're working in here. So I am like walking along this graph, right? I've got like road, boom, road, boom. I get to the bus stop, boom, right? Now, from the bus stop, from this bus stop, I want to like board buses, right? So like, there's going to be kind of like an n-dimensional, like you can kind of imagine that this stop exists as a singular point. I guess it doesn't. Let me think. If we were to like represent this as a graph, you almost have like stop, you have stop 4 and stop 5. And the graph has connections between stop 4 and 5 at specific times, right? So you have stop 4 at like 50 seconds and at 55 seconds. And these are connected. So it's almost like each stop is like this like, you know, n-dimensional stop with connections like between these. Right? And so you could almost imagine that your connection from like your normal OpenStreetMaps graph to the like transit graph is like an equal length edge to all of these nodes, right? All of these are the same length is like how you could think about this. And so I wonder if my initial strategy of working with like 5,000 bus stops and just kind of trying to consume them all, I wonder if that like doesn't make sense. Thinking. So you can immediately discard any trips that are before you, and you can discard trips that are way after you. I guess there's like this concept that you wouldn't want to take the same, you wouldn't want to like consider the same trip twice, right? If I have like a stop between 3 o'clock and 3:05, like why would I take the one that goes from 4 o'clock to 4:05? Like that doesn't really make sense. But I guess I have to consider both paths, maybe, right? You can imagine maybe you have this bus that goes at like snail pace, and so you get on it at 3 o'clock, but you don't get to the next stop till 4 o'clock. But like if you took this other bus, you would get there at like 3:30. Right? Like you can like model like express buses that way. In which case, you don't really know which one of those you're gonna want to take until you like look at them and say like, oh, this one takes longer, right? So that's something to consider here. I wonder if this formulation of the problem makes sense, right? Because if we formulate it this way, you're just still working in graph space, which is really nice. Everything just has like a connection and a node instead of trying to do something clever. I wonder if it makes sense to try to tie these things to routes in some way, right? Like, why would I want to take, like, do I want to take the 25 that comes in an hour when I could have taken the 25 now? So maybe we kind of can limit these trips by the first occurrence on that route when you arrive there. I think that makes sense because that will limit the search space heavily. Okay, so we want to do something like limit one trip per route given time of arrival. I think that makes sense. We have a little bit of a problem with if we use the approach of trying to greedily consume every stop. Like, so before, but my initial thought here was we try to fucking rip the bus graph as fast as possible, right? And then you know that, like, then you can kind of do the rest of the graph walk like normal. But that might not really work because the assumption of A star is that the first time you get to a node is the fastest, right? So if we kind of like go over here and we rock over here and we're like, okay, we get on the bus and the bus takes us here and the bus is going to take us here for another like 50 minutes, right? Like this is like a 30-minute wait. And this is like, we could like walk here way faster, right? This is like a 5-minute walk or something, right? So, I mean, we could just consider that when you get off the bus, you might be able to kind of say that you're in like a pending state. So you wait until the next time you arrive at that node through some other path. Because I think the cost to get here will be accurate, but we might hit that node too early. So there's something to think about there where like first stop off bus may not be the correct. It may not be the fastest way to get there. So there's something to think about there. What else? I think I like the idea of limiting to the first trip per route. I'm pretty sure I like that. Now, there's kind of something fucked up where sometimes the same bus route will take different paths at different times of the day. But I think I just won't consider that a problem. I just won't think about that. Okay, is there anything else here? I think I'm realizing now that there are like, I need to think about this more before steamrolling ahead. Like, I think that like I've just kind of had a revelation that like this get transit neighbors thing is like broken. And so I don't want to just plow ahead doing something now without thinking about it. It's 3:45, which means that it's kind of like a good natural time to stop. We usually try to go till around 4. And yeah, I don't want to like plow ahead without thinking about this there. So I think I'm going to call it here, which is, you know, I think we got through a lot of stuff. I don't really know what it all was, but we did stuff. We got the trip times into the client. We can now plan around those trip times. It's just we don't know what we want to do with them. So we made some progress. I'm going to come back tomorrow, hopefully refreshed with an idea of how I want to handle this stuff. I'm pretty sure, like at this point, it feels like treating it like a 3-dimension, like another dimension, adding time as like another dimension to the graph feels like it's going to work, but I just want to think about it a little bit before plowing on. So thanks for watching, guys. I hope you liked what you saw. If you did, we stream most days at around 12:30 Pacific time to around 4 o'clock Pacific time. If you're watching on YouTube, you were seeing the section from 2 to 4. There is a section from 12:30 to 2 where we do kind of like code cleanup and like whatever stuff. Like the mainstream, I consider this like, I call it like prototype mode, where you kind of just rip shit and hope that you end up somewhere okay. But often you leave a wake of destruction in your path that needs to be cleaned up. And so we kind of look at that in happy hour, or like small tasks that don't really deserve their own stream or their own YouTube video. So if you want to check that out, those are archived on Twitch and Patreon. If you're on Twitch, you can check out the YouTube channel. There's a bunch of stuff in here if you want to check it out. Organize the playlist. We're now working on this map, but you know, we've worked on QR code decoder. We've worked on image to text neural network. We've worked on an operating system. We've worked on zlib implementation. You know, there's stuff in there if you want to go check it out. Otherwise, you know, typical like, subscribe, Twitch Prime shit. And let's say bye YouTube, goodbye YouTube, and Twitch, let's find someone to raid.